Hello. Today we're going to look at the 2016 AP Statistics exam. This is free response problem number 6. So let's read a little bit about it. It says, newspaper in Germany reported that the more semesters needed to complete an academic program at the university, the greater the starting salary of the person in that first year of a job. So they used a random sample of 24 people, and we can see a scatter plot below. And what we notice is our explanatory variable here, X, or explanatory variable, is the number of semesters, and Y, which is our response variable, is the starting salary in thousands. So it's good to look at a data point maybe and make sure you know what the graph's telling you. So let's say I pick, this data point down here. So it looks like this person spent about 10 semesters in school. In case you don't know, a semester is a half a year, so the person's been 5 years in school, and their starting salary was somewhere around $32,500. If we look over here at this point that's at the end of the data set, it looks like this person has spent 20 semesters in school, so that's about 10 years, and it looks like their starting salary is somewhere between $50,000 and $55,000. So it's always good to get a picture of look at the graph and try and decide what the data points are really telling you. Two quantitative variables here. So we think that spending more time in school will maybe lead to the person having higher starting salary. So let's look at part A. Does the scatter plot support the newspaper report about the number of semesters and starting salary? Well, if we look at the general trend of the data, it does seem to be heading upward like this. It looks like it has some kind of positive slope. So that would lead me to believe that, yes, it is supporting what the article is saying. As semesters goes up, as X goes up, Y goes up also. That's what we can say. If you wanted to use a slightly more, I guess a little bit more sophisticated way to do this, there is a way to estimate a least squared regression line for a set of data by doing the following. You draw an ellipse, which is basically like an oval, around your data. And then you look for places on the ellipse where the tangent line would be vertical. So just in case you forgot what a tangent line is, they happen in a couple of math classes. Let's use a different color. So say you have a circle and you have a line that goes by that just touches the outside of that circle. We call that a tangent line. The other subject tangent lines show up in a lot is calculus. So if you have a function graph like this, and someone says, well, what's the slope of the tangent line at a particular point? So we can draw tangent lines at any point along this curve here and ask about the slope of it. So what we're going to do here on the ellipse is look for the vertical tangents, and they seem to be happening here. Here's one vertical tangent line, and the other vertical tangent line is over here probably. It's an estimate. It's not perfect. So if you take the 2 points where the vertical tangent lines touch that ellipse you drew, you can draw a line through that, and that line is a really good estimate for the least squared regression line. It's not a common thing to talk about, but it's fun to look at. Either way, you want to comment here that since the number of semesters goes up, we see an increase in the starting salary, so it is supporting what the article was saying. Okay. Another common thing that happens here, they give you the output from a software program for the linear regression. A couple of things to keep in mind. Next to the word constant is always the y-intercept. And then underneath the word constant, you'll see a word which is your x value or your explanatory variable for the problem. So if you were to look at a different problem, you wouldn't see the word semesters here. You'd see a different word depending on what the explanatory variable was. And next to that is the slope. So part B, identify the slope of the least squared regression line. So we can say that the slope is equal to 1.1594, and then interpret it. So you have to interpret this in context. So the way I usually do that, I take my slope, I write it over 1, and I remember that slopes are always change in y over change in x. That's what I would remember. Slope is change in y over change in x. So remember, x is counting the number of semesters, right? This is semesters in school, in college, and y is the starting salary of the graduate in dollars. Okay, so what can we say here? We can write a sentence as this. Remember, every time x increases by 1, y would increase by 1.15. So we can say something like, for every additional semester in school, starting salary increases by, and remember this is in thousands, so we can say $1,159. And actually I should be, we should say starting salary is predicted to. It's very important to use the word predicted because that's all regression lines do. They make predictions. They're not exactly what's going to happen in real life. Okay, let's take a look at the second part of the problem. An independent researcher received data from the newspaper and conducted new analysis by separating the data into 3 groups based on the major of each person. So you've got this little key on the side here. It might not be obvious originally, but if you look at the original graph, let me just get a clean version of it for you without all that writing on it. So if we look in there, then these set of points here, those set of points in the middle of the picture, sorry about that, those set of points there are the same as these set of points. It's just that the researchers gone to the trouble of coding things. So these hollow dots are business majors. We can see that over here in the chart. And the little stars in the middle are physics majors, and the X's are chemistry majors. So let's see what it asks. Based on the people in the sample, describe the association between starting salary and number of semesters for business majors. So we look at just the business majors, just the circles. That's this cluster of data. And if you want to do the ellipse trick again, you could do that. You could draw your vertical tangents and then draw the least squared regression line going through it. If you don't want to do that, don't worry. If you don't want to get confused by that, you can just draw a line through that data set, and you can see that that line has a negative slope. So you can mention that, negative slope. You can say as x increases, y decreases for business majors. In other words, this relationship is the opposite of the overall trend in the relationship that we learned about in the first part of the problem. Based on the people in the sample, compare the median starting salaries of all the majors. Okay, so you can actually do a pretty good job getting the medians here. So let's say we were to look at just business majors for now. What I would do is we want to get to the salary that's in the middle of all these circles. So what I'm going to do is I'm going to mark off that dot and that dot because one's the highest and one's the lowest. Then I'm going to knock off the next highest and the next lowest, and the next highest and the next lowest. Maybe that's that one there. And then somewhere around here, then the median's probably right around there. So for the business majors, make a little chart here with the medians. For the business majors, I'm going to say it's about $37,500. Let's do the chemistry or the physics majors next. So physics majors, knock off the lowest dot and the highest dot, the next lowest dot, the next highest dot, the next lowest and highest. There you go. And then you've got these two. So somewhere in the middle of those, maybe that's around 48,000. And there's a range of answers that would be accepted here. And then lastly, let's check for chemistry. So these guys, highest, lowest, second lowest, second highest, third lowest, third highest, right? And then we get to the middle, we come across, that looks about to be 55,000. Not so bad. Okay. Based on the analysis conducted by the independent researcher, how could the newspaper report be modified to give a better description of the relationship between the number of semesters and the starting salary for people in the sample? So they could say something like this. I'm not going to write it out, but I'll say it to you. You could say, well, overall, when all the data is combined, we see a relationship, whereas the number of semesters goes up, the starting salary increases. But within each of the majors, within business majors, physics majors, and chemistry majors, in each of those programs, we see that the longer that a student spends in school, the more semesters they spend in school, the lower their starting salary will be. So, should remind you a little bit maybe of Simpson's paradox. Anyway, that's it. Thanks for watching.